In this question, we have to find out the equivalent gate of this complete logic gate and this complete logic gate. So for that, let us first of all write down the final output of these logic gates. So we know that this is a NAND gate, and in NAND gate the output is A dot B bar. Now both the input are same, so we can say that the output will be A dot A bar, and A dot A is A itself, so it would be A bar, and in the same way it would be B dot B bar and it would be B bar, and here it would be A bar dot B bar whole bar. Now by De Morgan theorem, we know that A bar dot B bar are equivalent to A plus B whole bar. So by double bar it would be cancelled. So it would be A plus B, which is the OR gate. And in the second case, you can see that this is A dot B bar, and this will be A dot B bar dot with A dot B bar whole bar. So it would be again A dot B bar and bar. So it would be A dot B. So it is AND gate. So the correct option is A. Now let us move on the next question. In this you can see that this is a combination of logic gates, and we have to find out the output of this logic gate for two cases. In the first case, A, B and C are equal to 0, and in the second case, A and B are equal to 1, while C is equal to 0. So let us talk about the first case. So in the first case, we can see that this output is output of, this is OR gate, so it would be A or B, and this is C. So this is obviously NAND gate. So the output of NAND gate is A or B dot with C and whole bar. So you can see that if A is 0, B is 0 and C is 0. So 0 plus 0 dot with 0 bar. So it is 0 and 0 bar is 1. So its output will be 1. And when A and B is 1, so 1 plus 1 dot with 0 bar. Now 1 plus 1 will be 1, 1 dot 0 will be 0, and 0 bar will be 1. So the correct answer is D. Now let's move on the next question. In this question you can see that we have to identify that logic gate whose output is 1. So output of this logic gate will be A dot B. So A is 1, B is 0, so it is 0. The output of this logic gate will be A plus B bar, and A is 0, B is 1, so A plus B will be equal to 1, and 1 bar is 0. So it is also incorrect. Now in the third case, it is NAND gate, so it is A dot B bar. So this is 0 dot 1 bar. So 0 dot 1 is 0 and its bar will be 1. So it is correct answer. And this is XNOR gate. So in XNOR gate, we know that if both the inputs are different, then output is 0. So this is also incorrect. Now let us move on the next question. In this question, you can see that we have to identify that which gate is being represented by this logic gate symbol. So you can see that its both input are same, so its output will be A dot A bar. Okay, because it is NAND gate, so A dot B bar, and if A is equal to B, so it would be A dot A bar, so it is A bar. So A bar is NOT gate. Now let us move on the next question. In this question you can see that this is A, this is A, and this is A dot B bar, and this would be A dot with A dot B bar whole bar, and again this will be B dot with A dot B bar whole bar. Okay, so you can simplify this. This is by De Morgan theorem, this is A bar plus A dot B, and this is B bar plus A dot B, and this would be let's suppose this is X and this is Y, so this would be X dot Y whole bar. Okay, so let us write down the value of X dot Y, and X is A bar dot with A, in fact A bar plus A dot B, A dot B, yeah, and dot with B bar plus A dot B. This is also, this would not be bar, yeah, so whole bar. So now you can again apply the De Morgan's theorem, and you can say that it would be A bar plus A dot B bar plus with B bar plus A dot B bar. Okay, and now again we apply the De Morgan's theorem, so it would be A dot with A dot B bar, and this will be plus B dot with A dot B bar. So let us take A dot B bar common, and it would be A plus B. Now let us draw the truth table. So this is A, B and Y, 0, 0, 0, 1, 1, 0, 1, 1. So when A and B are 0, this term will be equal to 0 dot 0 is 0 and its bar will be 1, and A plus B, this is dot, so A plus B is 0 plus 0 is 0 and 1 dot 0 is 0, so it would be 0. And in the second case, if A is 0 and B is 1, so 0 dot 1 is 1, in fact 0 dot 1 is 0, 0 bar is 1, and this is 0 plus 1, which is 1, 1 dot 1 is 1, so it is 1. And in the same way, if B is 1, if B is 0, A is 1, then it would be 1. And in the last case, you can see that if A is 1, B is 1, A dot B will be 1 and 1 bar will be 0, 0 dot 1 plus 1 is 1, 0 dot 1 is 0, so it would be 0. So the correct option will be option A. Now let's move on the next question. In this question, this is a question of timing diagram. In this question, let us see that if we present these inputs A and B to this circuit, then what will be the timing diagram of the output. So this is A bar, this is B bar, and this is a NOR gate, so it is A bar plus B bar whole bar, so it would be A dot B. So this is AND gate, and in AND gate, let us see that when both the inputs are 1, output is 1. So in this case, output will be 1. When the both inputs are 0, then output is 0. When any one of them is 0 and any one of them is 1, then output is 0. In this case, it would be 0. And when both of them are 1, then it would be 0, then it would be 0. So this is 1, 0, 0, 0, 1, 0. Okay, so I think the correct answer will be 1, 0, 0, 0, 1, then 0, 0. So it would be A. Thank you.